Hi and welcome, we're Group NFMY2, and this is our Rolling Element Bearing Tribometer, made for testing thrust bearings. In this video, we'll show you the problem we tackled, how it works, and why it matters. There are 5 of us working together in this project: Hugh, Khaw, Rifhani, Harrith, and Aina. Before starting, did you know? Thrust bearing failure from friction causes major machine downtime. But commercial tribometers cost over $5,000. Our design is over 95% cheaper. So, what problem are we solving here? Well, commercial tribometers, especially those that can measure frictional torque in bearings, are really expensive. Prices can go from $5,000 all the way up to $100,000, which makes them unaffordable for most universities, students, and small research labs. Without access to this kind of equipment, it's hard for engineers and students to test things like friction, wear, or lubrication, which are super important in real-world mechanical systems. Even here in USM, we only have a pin-on-disc tribometer and a 4-ball tester, and neither of them can test thrust-bearing friction torque. That's where our idea comes in, and it connects directly to SDG 9, Industry, Innovation, and Infrastructure. It encourages innovation in testing tools, especially in places with limited resources. It also helps improve education, research, and promotes sustainable industrial practices by making friction testing more accessible. So here's our solution: a low-cost DIY tribometer. We designed and built it using affordable materials and simple electronics. It can measure frictional resistance and torque during thrust-bearing operation. It's perfect for hands-on learning, material testing, and even small-scale industrial use, whether in student projects or research labs. But how our prototype works? Here is showing the SolidWorks animation from isometric and front views. Next, we are showing the demonstration of our prototype. First, push button to activate the linear actuator. Then, the load sensor will measure axial force until it reaches approximately 20 kilograms, then automatically stops the actuator. Next, push button to activate the DC motor, which begins rotating the thrust bearing. Torque sensor detects and measures the frictional torque generated during operation. These readings are get from serial monitor. However, what makes our tribometer unique? Our tribometer features automated axial loading with precise force control, using simple button operation. It includes both load and torque sensors for accurate measurement. The total cost is under Rm 1,000, making it highly affordable. It's also compact and portable, ideal for classroom use or small research labs. Showing here is the core components and specifications, including a DC motor that can speed up to 425 RPM, a torque load cell that can detect up to 1000 Newton load and 10 Newton-meter torque, a linear actuator which can apply axial load up to 700 Newton, a bearing cup, and a thrust bearing. That's all for this project video. Don't forget to like and share our video. Thank you for your attention.